In this video, we are going to be going over the concepts of chapter 3, which have to do with matter and energy. At first, we are going to be looking at the classification of matter. The definition of matter is anything that has mass and occupies space. There are many objects and substances around us that are examples of matter. Some of them include the water in a bucket, even the bucket itself, a glass of water or milk, even the person that is drinking it is considered matter. The balloon, the gas inside the balloon, a car, a shirt, a pot, the content of the pot. And as you can see, there are many examples. As long as a substance or an object has mass and occupies space, is considered matter. Now, there are also examples of things that are not matter based on the definition in this slide. Understand that things that are not matter are going to be examples of things that do not have mass and occupy space. Some of them include memory, reflection, so the reflection of the sunlight in the water, rainbow, and even love. Okay? Now, that being said, that doesn't mean that love doesn't matter. It's just that when it comes to the definition of matter in chemistry, because it doesn't have mass and occupies space, then these four examples are things that are not matter. Now, understand that matter is going to be classified as pure substances and mixtures based on their composition. So let's first discuss pure substances. A pure substance is classified as a type of matter with a fixed or definite composition. There are two types of pure substances. Those are elements, which as you can see, they are composed of one type of atom and they can be found at the periodic table. The other type of pure substances are going to be compounds. And as you can see in the second bullet point, the definition of a compound is going to be two or more elements that are always combined in the same proportion. Okay? Now, an example of an element, as we can see here, the aluminum in an aluminum can is an example of an element. Table salt is composed of two elements. Sodium, and the word chloride refers to the element chlorine. Now, understand that in compounds, these elements are chemically combined. Now let's explore the other type of matter. So matter can also be considered a mixture. Understand that mixtures is a type of matter that consists of two or more substances that are physically mixed but not chemically combined. Understand that mixtures can be separated by physical methods. These physical methods are going to be techniques that are utilized in the laboratory in order to separate the components of a mixture. So, to give you guys an example, okay, of a physical method, here in the image that we have on the left, we have an illustration for filtration. And again, filtration is a physical method for separating the components of a mixture. In the process of separation, understand that there are different laboratory equipment that it is utilized. In general, a filtration system is going to have, and I'm going to label them on the slide, is going to have a ring stand, and this is the ring. The ring is where we place a funnel. Inside the funnel, as you can see, there's a white part right here. So this part is going to have a filter paper. And here we have a beaker, okay, that is going to retain the separation of these substances, okay? So if we have a mixture of a liquid and a solid, which is what we have in here. So here we have a mixture of liquid and solid. In the process of separating it through filtration, understand that specifically, and I'm just going to label it in different colors, the liquid is going to pass through the funnel with the filter paper and be collected in the second beaker. And then the solid content is going to be retained in the filter paper. So again, this is one of the techniques that is utilized in order to separate this type of mixture. But understand that there's many more and will be explored in the lab. Now, when it comes to mixtures, understand that they can be classified as homogeneous mixtures or heterogeneous mixture. So understand that first we are going to discuss what is a homogeneous mixture. By definition, a homogeneous mixture is specifically, again, composed of two or more substances, and the composition of a homogeneous mixture is uniform throughout. So what that means is that the different parts of the mixture are not visible, okay? An example of a homogeneous mixture is brass. Brass is an example of an alloy, okay? And alloys are going to be substances that come from the combination of different metals that are elements that are not chemically combined. Now, for example, in the case of brass, as you can see, we have the metal elements, copper and zinc, but understand that these are not chemically combined in the sense that they don't have a bond. So no bond is present in them. No bond is found between them. Now, when it comes to this, understand that other examples of alloys include steel, and bronze, just to name a few. Now, let's explore heterogeneous mixtures. In a heterogeneous mixture, as you can see, the composition varies from one part of the mixture to another. The important thing is that in a heterogeneous mixture, we are going to be able to observe the different parts. That's what it means when it says that the different parts of the mixture are visible. So in the example that we have on the image on the right, as you can see, this is a glass of water with pennies, and you can see the pennies in the bottom and the water in the top. So as long as in a mixture you can see the different components in it, understand that that makes that mixture heterogeneous. So the classification of matter based on composition goes as follows. Matter can be classified as a pure substance or as a mixture. When it comes to pure substances, they can be classified as elements or as compounds. Remember that in the case of compounds, these are elements that are chemically combined with one another. So there's a bond that makes them be together. When it comes to mixtures, we can have homogeneous mixtures. And there, remember that we have a uniform distribution, so you cannot see the different components of the mixture. And in the case that we have a heterogeneous mixture, understand that the different components of the mixture can be observed. Now, on part A of our worksheet in the class, we have a list of substances and we need to consider them and classify them as pure substances and mixtures. So I'm just going to do at this time numbers 1 through 10, so the column on the left. So sodium is a pure substance, okay? That is one of the elements in the periodic table. Water is a pure substance. Water is composed of 2 hydrogens and 1 oxygen. Sodium, the symbol is Na. I forgot to mention that. Soil is a mixture because, again, when we're talking to soil, we're looking at the different parts. There's minerals in the soil. There's the actual ground. There's leaves. There is like little pieces of wood. So soil is composed of different things. Coffee is a mixture. Oxygen is a pure substance. That's also an element, and the symbol is O. Isopropyl alcohol is a pure substance. It is composed of 3 carbons, 8 hydrogens, and 1 oxygen combined with each other. Carbon dioxide is a pure substance, and its chemical formula is CO2. Cake batter is a mixture. Air is a mixture because air is composed of nitrogen, oxygen, carbon dioxide, helium, and other gases. And lastly, chicken noodle soup. That is also a mixture. Make sure that you practice at home the rest of the problems.